Hi, welcome to an Arduino tutorial by Robojax. In this video, I'm going to show you how we can control this 60 ampere pulse width modulation motor controller module using Arduino with pulse width modulation. I've seen a lot of comments and requests that people wanted to control a motor controller with a board that is available with the knob, but they want to control it via Arduino, either by the knob or by the command. If you want to support me, I've launched my Patreon account. The link for my Patreon account is below this video. Let's get started with this. I've received a lot of requests through the comments and the video that I made for this module, that many people requested that how can we control this module instead of directly with a knob in here, to use Arduino to control this. In this video, we're going to modify this module and use Arduino Uno. I'm going to show you how you can control this using a knob with Arduino Uno, but also I'm going to show you how you can send any signal to control the speed of this without the knob, just directly based on some parameter. I have another video that I have done a full review and test of this. I'm not going to test those things. The link will be provided so you can watch that. I have another video explaining potentiometer or variable resistor to control a servo or something, and or measure the voltage of this. I will not go through that. The link will be provided for that as well. How it works is that this 555 IC is used, and this acts as a pulse width modulation, and the duty cycle is controlled by this module in this case, and the signal, which is pin 3. Let me show you here. This is the block diagram of the chip. Pin 1 is ground, 8 is VCC, and pin 3 is the output. There is a small dot here on the PCB and also there is a line on the chip. It's telling you that pin 1 is on that side on the left. So 1, 2, 3, that's the third pin, and there is a path of this PCB, which you see this label is written. It's coming to this diode, which I soldered, and then as a wire, and also underneath it goes to all those 3 diodes. There is another diode here, another diode here, another here with a resistor. So all 4 are connected to the gate of this. And from this one also the same way, we have a path here that is coming to this chip, to this diode, and from here it feeds to the gate, and then this path in here, this line is exact a line that is going. So what I'm going to do is I'm going to cut this path here with a sharp knife on the PCB, so the signal cannot reach from IC to this, and we are going to connect this to Arduino, so we will feed our own signal to this portion. And for this one also, I'm going to cut this line, this area, and the signal will not reach, so we can send from Arduino. This chip, the pin number 3, is coming to this diode, and from here it goes all the way for these 4 Mosfets, and from this chip it comes here to this diode, if you can see it, this diode and this resistor. So the same way we have another diode here, another diode, another diode. So this line is for this chip, for output of this chip. I'm going to solder 1 wire in here to see it, and 1 wire in here to see it on oscilloscope. And here I've soldered 2 wires. This is connected to this point, to the U3 pin 3. This is the U2 pin 3. So I have 2 wires. I'm going to watch it on oscilloscope. I've now connected the power. As you can see, this is power. 12 volts have been connected to this, and we have signal here. Let me connect the channel 1, and that is the channel 1, this section, and this is the channel 2. Let me connect it so you can see the waveform. And as you can see here, they're on the same phase, so there is no phase difference in between them. If we bring one over the other one, this is exactly the same. There is no phase difference. As you can see, if I put them, they are exact. And so the on time and off time are exactly the same. And let me control it. Let me turn it off, what it does. Okay, so this turns it off, and then when you put it to minimum, this is as if all the signal is low. When I go to the maximum, this is the duty cycle, the amount of time the motor is running slowly, and if I increase it, this area determines the speed of motor. As this increases, this decreases, the low decreases and the high increases, the motor runs fast, and now it's almost at the maximum, almost maybe about 95% or 90%. So they keep these two separate, even though they could do it the same way. To be consistent, we will generate two simultaneous pulses modulation. And as you can see, the frequency is 15.6 kilohertz. I've spent quite some time making this video, preparing the code, recording it and uploading it so you can learn. The least that you can do for me is to hit the subscribe button and leave the notification on. It's greatly appreciated. Thank you. So let's cut the first one. I have a very sharp blade here. I have here the continuity tester is running, and as you can see, we heard the beep. I've made the cut here now. This is the cut, and then let me check with the pin 3. As you can see, there is no beep. On the PCB there is beep on this side on pin 3, so pin 3 is disconnected to this portion. And for this one now, I made another cut in here. Let's put that and check it. Yes, so this path is already also cut. As you can see in here, I did the cut, and there is another cut. And here I've soldered this one wire at this point. This is the ground, and I've soldered one wire at the middle, 2 pin on the other side, 2 pin on the other side, at the middle one, exactly between these two. So this is a pin that the wire is, this path is connected to. So this is the input. Now we have 23 volts input, and these two wires that I have connected, here it shows the voltage, and the voltage is around 11.9 or 12 volts at 23 volts. I want to power Arduino from these two pins. Let's reduce the voltage and see what it does when it goes to 12 volts. This is the input. I'm reducing it. It's being reduced. Now let's see. So 12 volts, 9 volts will give you 5 volts. Arduino cannot function through the pin that I'm connecting, which I'm going to show you next. So this module, if you connect it between 12 volts and higher, and here the input is, as you can see, 22 volts, the output is around 12 volts. Let me increase the input more. And as you can see, the input is 36 volts, the output is 12 volts. The output voltage will always be 12 volts. And now I've connected the power here. I've supplied 12 volts to the board, and before I connect this to power my Arduino, I will check again the voltage, making sure it gives me the right voltage. Here is my voltmeter. So I'm getting around 8.5 volts. So this is my power for Arduino. So this pin, the red between the two capacitors, the 8 volts, I'm going to connect it to the NVN pin. This pin is for external power. This is the same as if I connect it to this power adapter. So when I connect this, it goes to this regulator and supplies the voltage to Arduino. So this has been connected, and then the other one was the ground pin. I'm going to connect it to any ground in here or in here, so it doesn't matter. So when I connect it, now Arduino is powered up. And then we have two signal pin. One goes to pin 5, one goes to pin 6. If you want to learn Arduino step by step in a structured course with all the library, code, schematic diagram and related material in one place, you can visit my course at udemy.com. Whether if you're engineering, mechatronic, college or high school student, or a hobbyist or a researcher, in this course you will start learning Arduino from ground up, and in no time your all robotics and cool mechatronic project will be running using Arduino. The link to my Arduino course is below this video. Let me now explain the code that I've prepared. I've defined pin 5 for pulse modulation pin 1, and for pin 2 I've defined pin 6. Remember that you cannot define all the pins as pulse modulation. Only pin 3, 5, 6, 9, 10 and 11, which has this tilt in it, can be defined as pulse width modulation. And then control pin, this is for potentiometer, in case if you use external potentiometer, and then use inside the setup using pin mode. Pulse width modulation pin 1, we define it as an output, that's pin 5. Pin 6 also as an output, and we define the serial monitor with 9600 baud, and inside the loop we use analog read to read the control pin that is connected to the potentiometer, and put the value in a pot value integer, and then this will be printing it for us on the screen. And then we get the pot value. Using the map, we get this pot value, which is from 0 to 1023. That is the analog pin value that you receive, and we are translating it between 0 to 255. 0 means 0%, and 255 means 100% duty cycle. And we are storing it here as a integer value, which is between 0 to 255, and then using analog write, we send it to pin 1. That value in here, it goes to pin 1, and also using analog write, it goes to pin 2. Pulse modulation pin 2. So this is actually pin 5, that's pin 6, and we wait for 1 second, and let's say make it 500 milliseconds, half a second, and it will continuously read the potentiometer. Here we are also printing this space. I changed this LN and removed it, so it prints the value with space. Also it prints the pulse modulation. Let me show you. So this is the analog value. You don't need it, I'm just demonstrating it. And here, if I rotate the potentiometer, if I go to maximum, you will see that we are reading 1023. The maximum is 255. If I go somewhere at the middle, it will be somewhere at the middle value, and if I go to 0, it is 0. Now this has been powered up, and I've connected a motor. This is not, this is very tiny motor with comparing to this that can supply. I've connected the 2 wires here. Arduino is also connected. Let me put this at the minimum. I go to the left, so now it's 0. Remember, the volume is now useless, but there is a switch. These 2 wires is for switch to turn this on, and pay attention to the light here. So now this is on. If I turn it off, you will see the LED is off. So this doesn't matter. Now I'm going to rotate this and hold this, because this will stopped. And here, if I remove it, if I remove the signals, it will turn off. Now if I connect one, it will start working, because one portion of this will be activated. Now to program this, make sure to disconnect the power that is coming from here. So I'm disconnecting the power from VN pin, connecting it to Arduino. And here, let's say how we can control this module. For example, if you want to send a motor to certain speed. Now I have set this. I'm sending 20%. This is to control with whatever percent of duty cycle. So I've written this function. It gets 20 and returns the value proportionally between 0 to 255. Here is the explanation of the function. And here it receives the value that you send. For example, the 20, it will be here as V, and the map function will get the V, which is between 0 to 100, and it converts it between 0 to 255, and the result of this will be returned. That is why that 20 will translate to some value, and will be here as PM pulse width modulation, and we send it to pin 5 and pin 6. And before, if I run it on the motor, here the value is 51. So 20 is 51. Let me now test it. Now I've disconnected. The power is not connected because this is powered up and Arduino is powered up with USB. This time we don't need this power. It can be connected only. I'm connecting the ground. And this is the 20%. And by the way, if I disconnect it, still it will work, but I have to connect the ground and power the Arduino using this. From this, send power to Arduino, to VN. Now this is 20%. And let me change this. Let's say you want to go with a 50%, upload it. So remember, 50% should translate to half of this, to 125. So it converts it to 127. And let me now connect this. I'm just connecting the ground so the motor will run faster. So I'm going to change the value. Let's change it to at 80% duty cycle, and it's around 204. Let me connect the ground here at the ground pin. And now if I disconnect it, just powering this up to the VN pin. Remember, if you connect this to 5 volts pin, you might burn the Arduino. VN is the right pin. Now this will have an effect, but remember, if you power Arduino with USB, this will not have any effect, because this is disconnecting and connecting this power. Thank you for watching. This was how to control a pulse modulation motor controller module from Arduino. If you learned something and like this video, please thumb up. If you have comment or question, post it at the comment section below. I try to answer and reply. Do not forget to subscribe so you can get updates of my upcoming videos.